Okay. So here we're going to identify the class width in problem number 1. All right, for the class width, you're going to take the distance between, or the difference between any two lower class limits, or the difference between any two consecutive upper class limits. So like this one, between 35 to 40, what would the class width be? 5. So here you can just do 40 minus 35, and that will tell you the class width is going to be 5. Okay. And then next would be the class midpoints. The class midpoints. Now the way we find the class midpoint would be take the lower limit plus the upper limit. Whatever that sum is, we divide by 2. So for the first class, that'd be 37, because we take 35 and 39 together. Divide by 2. 35 and 39 would be 74. And 74 divided by 2 would be 37. Now, once you find that first class midpoint, since we already know the class width is going to be 5, we can just go ahead and get the other class midpoints for the other classes by just adding that class midpoint to the first one. So if I add 5 to that 37, I'm going to get 42. Then add 5 to the 42, I'll get 47. Add 5 to the 47, I'll get 52. And then add 5 to the 52, I'll get 57. And then 5 to the 57 will give me, and then 62 plus that 5 would be 67. Bless you. Okay, and there should be 7 classes, so that means we should have 7 class midpoints here. Okay. Are there any questions? Well, finding the class midpoints. Now for the class boundaries. So to find the class boundaries, now this one, the way we're going to have to do that, we have to take that lower class limit for the first class, which was 35, and subtract 0.5 from it. So 35 minus 0.5 would give us 34.5. And then the 34.5, we can add 5 to that since the class width is going to be 5. That's going to give us 39.5. And then add 5 to that 39.5, that would be 44.5. And then 5 to the 44.5 would be, and then 5 to that would be 54.5. Add 5 to that would be, and then 5 to that would be, and then there's one more, 64.5 to the, add 5 to that. Okay, that would be it. Because we have to go 1/2 below and 1/2 above. Okay. So those are your class boundaries here. Now, are there any questions about problem number 1? Okay. Now, here we got data that represents the body mass index values for 20 females. Now, here we're going to use this data to complete problems 2, 3, 4, and 5. And in this case here, we'll start with problem number 2. Construct a frequency distribution beginning with a lower class limit of 15 and a class width of 6. Okay. So in this case here, we're going to start with the frequency distribution. Oops. Pretty much looks like this. So here we have the body mass index, or BMI. Then the frequency. Now we need to know how many classes they're going to be, since we're given the lower class limit of 15 and the class width of 6. Okay, so to find the number of classes for this frequency distribution, we always take the maximum value minus the minimum value, divide that by the class width. So what's the maximum number in this data set? 44. And what's the minimum? 17. So in this case, this will be 44 minus 17. Divide that by the class width. They tell you the class to use a class width of 6. All right, so now what's 44 minus 17? (44 minus 17) 27, and now 27 divided by 6 will give us 4.5. Now we always round up to the next larger number, so 4.5 will round up to 5. So that means we're going to have 5 classes to begin with. All right, so now for this left column, here's what we're going to do. We're going to start with the lower class limit of 15 as indicated. Now let's go ahead and find out what our other lower class limits are going to be. So if this is 15 and that class width is given to be 6, what will be the next lower class limit for the next class? 21. We add 6 since the class width is 6. Now let's add 6 to the 21 to get the next lower class limit. 27. And then add 6 to that, you'll get 33, and add 6 to that, that will be 39. And we stop right here because we have 5 classes that we're going to be dealing with. And these are whole numbers here. So to find our upper class limits here, if that's 21, what's one less than 21? 20. Okay, our data values are whole numbers, so that means our classes are going to be whole numbers. So that means here, we're going to add 6 to the 20. That would give us what? 26. Add 6 to the 26, you'll get 32. Add 6 to the 32, you'll get, and then add 6 to the 38, you'll get 44.
Okay,
So-
so, Mr. Lucas, so why did we just do 20? Is it because it's the lowest number?
What's one less than 21?
Okay, I got you.
Yeah.
Okay, so it's.
Yeah.
Okay.
Any other questions? All right, so now to find the frequency, we need to count how many data values from this table of data values, how many are between 15 and 20, and that does include 15 and 20. Okay.
Oh, no, 2.
Yeah, 1, 2, and 3. Because you got 17, 19, and then 18. So that means that there are 3 data values that are between 15 and 20. Okay? Number 20, from 21 to 26. And that does include the 21 and the 26, by the way. How many data values are between 21 and 26, including those endpoints?
8.
How much? 8? Because I see 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right, now for 27 to 32. How many data values are between 27 and 32, including the 27 and the 32? There are 5. Okay, because there's 1, 2, 3, 4, and 5. Might be missing one. Okay, 1, 2, 3, yeah, 4, 5. Okay. And then for 33 to 38, let's see. Let's see, 33, that's 1. 2, that's 37. And 33, that's 3. And now, 39 to 44, only 1. That's the number 44. And since there are 20 data values, you want to make sure if you add these numbers up, you should get 20. Let's see, 11, 16, 19, and then 20. We do. So this is our frequency table or frequency distribution for that data set. Are there any questions about problem number 2? Now, using this, we're going to create a cumulative frequency distribution. That's going to be problem number 3. Okay. So again, we have body mass index. Now here we're going to have cumulative frequency. Okay, now the way we're going to do the cumulative frequency distribution, we're going to use the phrase less than. And the way we do that is going to be the less than the second lower class limit, which is in this case 21. Because we're looking at data values, that's going to be less than 21. And my class width, of course, is still going to be 6. So if I add 6 to that 21, I'll get 27. Then next will be less than 33. And then less than 39. And then the last one will be less than 45. Now the cumulative frequency distribution, that's just going to be the sum of the number, the frequency itself, and any previous frequencies that come before it. So for like this one, the 3 here, that's for 15 to 20, which is less than 21. There are no numbers before that, so that means we just bring down the 3. And then less than 27, we include this 8 and the 3. If we add those two together, you'll get 11. Less than 33, that means we take this 5, add that to the 2 other frequencies that come before it. So 5 plus 8 and 3 would give us 16. And then less than 39 would be the one that has 33 to 38, which is 3. Add that to the other frequencies that come before it, you'll get 19. And then the 1 added to the other frequencies before that would be 20. That's our cumulative frequency distribution. Okay. And I do need to bring this up. Are there any questions about problem number 3? All right, number 4. We're going to use a frequency distribution in problem number 2 to construct a histogram. And we're going to use the class midpoints in the horizontal scale. Okay. So in my opinion, the class midpoints would be best to use. Okay, so here's my horizontal and vertical axes. And of course, there are 5 classes. Now, from 15 to 20, that's the first. Let's find out what that class midpoint is going to be. That's going to be to find that out, we take the lower and the upper class limit, add those two together, and divide by 2. That would give you your class midpoint. It's 17.5. And I'll even write this off to the side here. 15 plus 20, divide that by 2. That'll be 35 over 2, which is 17.5. And if we know what the class width is, which is in this case going to be 6, let's add 6 to that first class midpoint to get the others. So 6 to 17.5 would give us 23.5. Add 6 to that, you'll get 29.5. Add 6 to that, 35.5. And then add 6 to that, 41.5. And we'll label that as body mass index. Now let's see what we got here in that frequency table in number 2. This is from 1 to 8. And by the way, you'll have a vertical and a horizontal axes on your exam. Okay. So if we look at what we got in problem 2 for that frequency distribution, we can see that that 17.5 is for the 15 to 20. And that frequency there is 3. So we're going to be drawing a vertical bar at 3, which would be right here. And we're going to try to have the mark at the center of that bar, like this. And then 23.5 is for 21 to 26. That frequency there is 8. So in this case, the vertical bar would be at the height of 8. Okay. And then for 29.5, that midpoint is for the 27 through 32, and its frequency is 5. And then for the 35.5, That's for the 33 through 38, and this frequency is 3. So it's going to have the same height as the one for the 17.5. And then finally for the 41.5, that's for the 39 to 44, it has a frequency of only 1. So that bar would be at the height of 1. Okay. All right, are there any questions about problem number 3? I mean number 4, constructing the histogram. Okay. All right, in problem number 5, for the body mass index values, construct a frequency polygon. For the horizontal axis, we're going to use the class midpoints. Okay, so let me move this out the way. Now again, we're going to use the class midpoints here. So I need a horizontal and a vertical axis. And keep in mind, a frequency polygon is always going to be a closed figure. And if we're using class midpoints, then here, this will be 17.5. And then the next one would be 23.5. And then 29.5. 35.5. Then 41.5. And since the class width is 6, what would be the next class midpoint? Has to be 47.5. And I'm doing that because the frequency polygon has to be a closed figure. Okay. So I'm going to start here with 0 here. 0, 0, that's the origin. And then for 17.5, that frequency was 3. And then for the 23.5, that frequency was for 8. And that's referring back to that to problem number 2. And then 29.5 had a frequency of 5. And then it was 3 for 35.5. And then 41.5 had the frequency of 1. And there was no class for the midpoint of 47.5. So we put a dot on the origin, on the x-axis. And then all we do here is just simply connect those dots. So if we connect the dots, just like this, you will have your frequency polygon. Okay. All right. Are there any questions about problem number 5? Any questions? All right, now problem number 6 is the data below represents the actual high temperature for 14 consecutive days. Use the temperatures to construct a stem plot. Okay, so pretty much, let me draw the stem plot over here. If you recall, the stem plot is just a vertical line. The stems are on the left-hand side, and your leaves will be on the right side. So by looking at this data set, the highest number is what? What's the highest? 87, and what's the lowest? 50, okay. So we're going from 50 to 80. So my stem's gonna start with the number 5 for 50, then 6 for the 60s, 7 for the 70s, and 8 for the 80s. All right, so now for the 50s, which is represented by the 5, we fill in our leaves. So for the 50s, we have this 59, 52, 50, 58. And we put those leaves in numerical order. So what would go first? The 50, and then 52, 58, and 59. Okay. And then for the 60s, it's just 67. So we put a 7 here for that to represent 67. And then for the 70s, start with 71, 72, 77, and 78. And then finally for the 80s, 80, 81, 85, 85 again, and 87. So even if the data values repeat, you have to account for every single one of them. Okay? And there are 14 data values, so that means we better have 14 leaves here. That's 5, 9, 14, and we do. So this is what our stem plot or stem and leaf plot would look like. Okay. Are there any questions about problem number 6? Okay. All right, now problem number 7. This is where we go into the descriptive statistics, the measure of center and the measure of variation. The students participated in an experiment to test their ability to determine when 1 minute or 60 seconds has passed. The results are given below in this data set, and there are only 5 of them. It's going to be a small data set, but you're going to use that to find the following. You're going to find the mean, median, mode, mid-range, range, variance, and standard deviation. So in this case, it will start by finding in part A the mean, which is in this case going to be x bar. To find the mean, we always take the sum of all the x values and divide by the number of data values we have. And in this case here, our data values are going to be 57, 53, 66, 69, 52. And that's divided by how many data values that we have here? 5. So now if we add 57, 53, 66, 69, and 52 together, you're going to get how much? 297. And if we take 297, divide that by 5, you're going to get what? 59.4. So the mean of this data set would be 59.4. Okay. All right, part B is finding the median of this data set. Now, first of all, you want to make sure that your data values are in numerical order from least to greatest. So in this case here, let's start by putting those numbers in order. Start with 52, 53, 57. Okay. So our data set is in numerical order. The way we find the median, we take the middle number. It'd be 57. Because the way you can do that is cross out the numbers on the end, on the left side and on the right side. So you can see here that median, sometimes they use this notation X with the tilde for the median. That's 57. Now, had it been two middle numbers, then you'll have to take the average of those two middle numbers. Okay. Any questions on part B? Now, part C is the mode. There is no mode. So you can just say none or no mode, because the mode is the one that occurs the most frequent. Okay. Now, part D is finding the mid-range of this data set. Now, to find the mid-range, we take the sum of the largest and the smallest data values and divide by 2. What's the largest number? 69. And what's the smallest? 52. So add 69 and 52 together, you're going to get 121. And 121 divided by 2 would be 60.5. Okay. Are there any questions about finding the mid-range? Okay. Part E is finding the range of this data set. That's, of course, taking the largest number minus the smallest number. Well, the largest is 69 and the smallest is 52. It'll be 17. Okay. So the range there of that data set would be 17. Now, part F is finding the variance. That's where we use that shortcut formula, which only involves just the x and just x squared. So the x would just be, now of course, I'm writing out the numbers that are in numerical order. And I think we found out what the sum of these numbers were. That was 297. That was back when we found the mean of that data set. Okay, now we need to find what the square of each of these x values are going to be. So if I square the 52, I would get 2704. And if I square the 53, I would get 2809. Square the 57, 3249. Square root of 66, 4356. And then square root of 69, you'll get,
4761.
okay. Now we're going to add the sum of the x squares, or obtain the sum of the x squares. Okay. What would the sum of these x squares be?
17,879.
Right. 17,879. Now we're going to use those to find out. And of course, n is going to be 5. There were 5 data values there. So this is how we find the variance. That's s squared is equal to your n, which is the number of data values, times the sum of the x squares, minus the sum of the x's. That would be squared divided by n times n minus 1. So our n in this case, that's going to be 5. So it'll be 5 times the sum of the x squares. We found that out to be 17,879 minus the sum of the x, which was 297. And that 297 will be squared. All that's divided by n times n minus 1. N is 5, so it'll be 5 times the quantity 5 minus 1. So I'm going to calculate the numerator and the denominator separately. So in this case here,
Oh, so do it separate first.
yeah,
Okay.
it would be, it's easier to do it separately and try to put all that in the calculator. You don't want to do that. Let's see, 5 times 17,879 minus 297, and then x squared to square it. So that numerator is 1186 divided by, and this part I can do mentally, like doing 5 minus 1, that would give us 4. 4 times 5 is 20. And then 1186 divided by 20. 59.3. So the variance of this data set would be 59.3. Okay. Now part G is finding the standard deviation. And to find the standard deviation, you just take the square root of the variance, which is s squared. And s squared was 59.3. So if we take the square root of 59.3, you get how much? 7.7. And you'll round that off to 1 decimal place. That's because the data set is all whole numbers. So the standard deviation for that would be 7.7. Okay. Are there any questions about problem number 7? Okay. Now, problem number 8 deals with not usual, significant values, whether they're significantly high or significantly low. And it says that a certain group of test subjects had pulse rates with a mean of 84.1 beats per minute and a standard deviation of 14.0 beats per minute. Would it be significantly high or significantly low, or not significant, but one of the test subjects to have a pulse rate of 92.1 beats per minute? Okay. So in problem number 8, here we have something that has a mean, which is going to be the Greek letter mu of 84.1, and the standard deviation, sigma, of 14.0. Okay, so here we have to do mu minus 2 times sigma, and also we have to use mu plus 2 times sigma. So our mu was 84.1 minus 2 times sigma, that's the standard deviation of 14.0. So using our calculator, 84.1 minus 2 times 14.0 will give us 56.1. And then for mu plus 2 times sigma, that's just 84.1 plus 2 times 14.0. Okay, 112.1, yeah. So what that means here is this: any data value that's less than 56.1 would be significantly low. Any data value that's greater than 112.1 would be significantly high. Any data value in between those two would not be significant. So I'm going to say not significant would be between 56.1 and 112.1. And it says here, would it be, they say unusual, but we're using, would it be significant for one of the test subjects to have a pulse rate of 92.1 beats per minute? It's not. Okay, so we can say here, that a pulse rate of 92.1 beats per minute is not significant. Okay. Are there any questions about problem number 8? Okay.
So if it's outside of those numbers, it'd be significant?
Yeah.
Okay.
Any other questions? All right, problem number 9. This deals with the empirical rule or the normal curve. It says that heights of men on a baseball team have a bell-shaped distribution with a mean of 185 centimeters and a standard deviation of 4 centimeters. Using the empirical rule, what is the approximate percentage of the men between the following values? Then part A, they say 173 centimeters to 197 centimeters, and then part B, 177 centimeters and 193 centimeters. All right, it would be best to draw the normal curve to see what's going on. And our mean is at the center of that curve. And we're told that the mean is 185. The standard deviation is 4. So if I go 1, 2, 3 standard deviations to the right, and that this is 185, and our standard deviation is 4, we just simply add 4 to the 185 to get 189. And then add 4 more to that, it'll be 193, and then 4 more to that would be 197. And then 3 less than that, subtract 4 from the 185, you'll get 181. Subtract 4 from that, you'll get, and subtract 4 from that. All right. Now, of course, this represents x minus 3 standard deviations from the mean. So let me fill that in. And then x bar minus 2 standard deviations, x bar minus 1 standard deviation, and then x bar plus 1 standard deviation, x bar plus 2 standard deviations, and x bar plus 3 standard deviations. Okay. Now, the empirical rule does say that within 1 standard deviation of the mean, you have 68% of your data values falling in between those, within that. And then 95% of the data values fall within 2 standard deviations, and 99.7% fall within 3 standard deviations of the mean. So in this case here, in part A, 173 centimeters and 197 centimeters. That's going to be from here to here. What percentage fall within those two? 99.7, because they're both within 3 standard deviations of the mean. So 99.7% of those heights of men on a baseball team will fall within 3 standard deviations of the mean. Okay? And then part B is 177 centimeters and 193 centimeters. 95%, because here's 177, here's 193. Those two numbers are within 2 standard deviations of the mean. So that means 95% of the data values are within 2 standard deviations of the mean.
And what's the number if it was 1 standard deviation again?
68%.
And will we ever have a scenario where it's just just the 185 there, where it's 1?
No.
Okay, never a scenario?
Because the 185, that's the mean. Okay. Any other questions? So you just,
My curve, so our curve need to look like that on the test, or?
yeah,
Okay, I can try.
just do your best on it. Just remember the 68, 95, 99.7 rule.
And what,
68% means within one standard deviation on the mean. 95% represents within two standard deviations of the mean, and 99.7% represents within three standard deviations of the mean. Any other questions? And finally, number 10, a certain animal body temperature has a mean of 90.89 degrees Fahrenheit and a standard deviation of 0.82 degrees Fahrenheit. And they wanted to convert 89.79 degrees Fahrenheit to a z-score. And then, is such a temperature significantly high, significantly low, or not significant? Okay. So here's what we have. The certain animal body's temperature has a mean, that's your X bar, of 90.89 degrees Fahrenheit, and it has a standard deviation of 0.82 degrees Fahrenheit. And in this case here, we have 89.79 degrees. And we want to convert that to a z-score. So z in this case is going to be x minus x bar divided by the s, which is your standard deviation. The x value is at 89.79 degrees Fahrenheit. And then minus what x bar is. That's your mean. 90.89 divided by s, which is 0.82. All right. Now, if you really want to do all of this in the calculator, you can, but I would suggest putting this in parentheses. And z-scores, as you mentioned, can, and I heard negative, so, which in this case, z-scores can be negative, so it'll be 89.79 minus 90.89, that has to be in parentheses, divide that by 0.82. You then hit enter. The z value is always to two decimal places. So what would this be to two decimal places? Negative 1.34. All right. Now with z-scores, we always use the range from -2 to 2. Anything that's not significant would be from -2 to 2. So would this be significantly high, significantly low, or not significant? Not significant, because negative 1.34 is between -2 and 2.
Say again, so not significant is negative?
Negative 2 to 2. Okay.
And then -2,
Less than -2 would be significantly low. Greater than +2 would be significantly high. That negative 1.34 is within the range of -2 to +2. So here, we can say here a temperature of 89 .79 degrees Fahrenheit is not significant. Are there any questions about problem number 10? Or are there any questions about what will be on exam number 1?
Is it also gonna be 10 problems?
Yes. And they'll be similar. Okay. Any other questions?